So now that we've had some practice doing SOHCAHTOA and Pythagorean theorem to find the missing sides of triangles, now we're ready to start applying this skill to situations in real life. You've already done a little bit with problems with the football fields last week and so on. This time we're going to be doing a problem involving a sailboat. Now, I should preface this with well, actually, no, I won't preface it with anything. I'll just start reading. So, a sailboat is in trouble, and the people on board are considering trying to swim to shore. A lookout station on shore tells the people that they are 2.3 miles from the station. Okay, so there's the sailboat, right? And then there's the station. And that the line from the station to the boat forms an angle of 35 degrees with the shoreline. Okay, so you can see the 35-degree angle right here. And you can assume the shoreline is straight as shown in the diagram. Okay, so we've got all this information. Sailboat's in trouble. They're 2.3 miles from the station. And the people are capable of swimming 1.5 miles. Will they be able to make it to shore or should they call for help? Explain. Okay, so let me just preface this by saying, if you're actually in a sailboat and you're in trouble, please don't be doing trigonometry. Don't be doing SOHCAHTOA. Like, do something a little more useful because your brain is not gonna be like, I don't know about you. If I'm drowning, I'm not about to pull out my like graph paper and start like, doing like sine and cosine. I'm gonna be, you know, calling for help, like trying to get a lifeboat going or something. But anyway, this is the problem that we're given. And so your job is to, as a group, do a write-up of it. So basically, solve the problem, show your process, okay? And so that's going to be half of your, that's going to be part of your group write-up. The other part is going to be concerned with this problem. So the first problem has to do with the sailboats. The second problem has to do with the shadows. In the second problem, you've got, so some students were using shadows to find the heights of trees near their school. They used the diagram shown here to represent the situation. Okay. In this diagram, theta, the Greek letter theta, represents the angle of elevation of the sun. Okay, now you don't know what angle of elevation is yet, but we can see that theta represents this angle over here. Okay, and so we can kind of see, hey, even though I don't know what angle of elevation is supposed to be, I know that theta takes this spot in the diagram. S represents the length of the tree's shadow. Okay, now why does that make sense? So S is down here. You got the sun shining over here. So it looks like the tree's casting the shadow. Okay, I'm starting to see it. So like you've got your, I'm kind of just going to redraw the diagram, but like you've got your tree, right? You've got the ground, like that. Okay. You got the sun over here. God, that's so bad. And the sun is doing what it does best, is shining its light. La. And then the tree is casting a shadow onto the ground. Okay, and that shadow makes an angle with the ground. Okay, cool. So in one case, the students found that theta was 35 degrees and S is 50 feet. Okay, so right here, so here is theta, right? And over here, in this case, theta is 35 degrees. And S, what's S? S is the length of the shadow. And we say S is 50 feet, so S over here is 50 feet. Okay. And your job is to find the tree's height. Now, where is the tree's height? We could call that, I don't know, it's going up and down, so maybe, Y is usually going up and down, so we could call it Y. Okay? And this is just a, yeah, so from here, your job is to basically find this height, find the tree's height, okay? Um, Later that day with a different tree, they measured theta to be 60 degrees and s to be 20 feet. Okay, so then you're going to change, excuse me, you're going to change your value of s and your value of theta. So the shadow is going to be a little bit, you know, sharper angle. And you're going to figure that out. And then in general, for part C, you're going to create a general expression for the height of the tree in terms of s and theta. Okay. So here, what you're going to do is you're just going to put in the letters and manipulate them, and then you're going to get an expression that involves s and theta. So you're not going to get a number, you're going to get an expression. Okay. Yeah, and so what I'd like to see is just as a group work together, come up with a joint product. It can be a poster, it can be a Jamboard, it can be, you know, something on a sheet of paper, whatever, right? You know, it can look something like, okay, so, you know, sailboats over here, shadows over here, right? So maybe you have your drawing of the sailboat problem, right? Over here, obviously that's not a complete drawing, but you kind of get the picture, okay? You know, write a little bit about the problem, okay? And then you're going to show your process. Okay. And then over here, you're going to draw your, you know, diagram for the tree. That's a pretty terrible version of it there, but you get the idea. Write a little bit about the problem. Okay. Part A, blah, 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 math, right? B, blah, 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 math. And then for part C, you're going to do a brief explanation of what it's asking for, and then you should have your formula or your expression for the height of the tree. Okay, and again, this can be group or individual, but the names of everybody who worked on it should be somewhere on the poster. I don't know, maybe up here. Doesn't have to be exactly this layout, but this is sort of to give you an idea. All right, and you're gonna upload this to Google Classroom. And yeah, so I will be available to help you. If you are on independent study, feel free to send me an email. If you are in person, I'll be coming around. And yeah, get started on sailboats and shadows and applying trigonometry to semi-real life situations.